let's move on. So now, when we've got two vectors that we want to add together, we know that we can add them tip to tail, but if they don't form a right-angled triangle, it's sometimes not that easy to find out what that resultant vector is. So sometimes it's easier when the two vectors aren't at right angles to each other. It's easier to actually go find these x and y components, then add together the x and y components, and then use that in order to find the resultant. Okay, so if you've got this issue, you've got to find x and y components of each force. You're going to add together the x and y components in order to find a resultant x and a resultant y, and then you're going to use the resultant x and the resultant y in order to find f net. So let's see how that is done. Right, so in this instance here, right, I've got the x component and here the y component of that 30 Newton vector, okay? And at this point, I now know that if I'm dealing with the adjacent, I get to use cos, right? So we're going to take the hypotenuse times the cos of 25, right? So now I'm skipping that step where I take the cos 25 and I put it fx over the hypotenuse, right? So 30 times the cos of 25 is going to give us 27,19 newtons. Okay, 27,19 newtons, and this is of course towards the right. Okay, then that was this fx here, and then this fy here. Fy is going to be equal to, and now we get to use sine because it's opposite that 25-degree angle, and so we get 30 times the sine of 25, and then I shall use my calculator once more. 30 times sine 25 is going to be 12,68 newtons, and that's now going to go up. Okay, so we've taken our first force and we've broken up into x and y components, and now we are going to take the other force and we are going to break it up into x and y components. And I'm going to do it in a different color here, just to make it easy to see which one I'm working on. Okay, so there I'm taking the x and y components and I'm adding it together to give the original 15 Newton force, okay? And then the 20-degree angle is this here, right, which means that fx in this instance is opposite the angle and fy in this instance is next to the angle, right? So fy being next to the angle, I've got to use cos for, right? So 15 times cos 20 is going to give us an answer of 14,10 newtons. Okay, and this I now know is down, and then fx is the opposite that angle, which means I get to use sine. So then 15 times sine 20 is going to be equal to something, let's see, 5,13 newtons. Okay. Okay, and that is going to the left. Okay, right, so now if I go draw the vectors in on a new diagram and I only draw in this x and y components that I've broken that up into, we'll see that we're actually in a really good position because we can now add up the x and y components to find the resultant x and the resultant y. So I had this 14,10 going down. There was what, 27.19 going right. I'll put that here, 27,19. There's a 12.68 going up. Okay, and then there's a 5.13 going to the right. Okay, so now it's easy. We just add up the x and y components. So for the y components, I'm going to take down as positive. So 14.9 minus the 12.68 is going to give us 2,22. Okay, so we've got 2,22 going down. And then for the horizontal vectors, I'm going to take rightwards as positive. So 22,19 minus the 5,13 is going to give us 17.06. So then 17.06 is going that way. Okay, so what progress we've made? We've started with that. We broke it into that. Now we've got this after adding that together, but now we've got an x vector, a y vector. We've got two perpendicular vectors that we can now easily add together, right? So now we do the same as always, tip to tail, right? Tip to tail. And then we've got here the 17,06, right? And then here the 2,22. And then we know the resultant vector starts at the start, ends at the end, right? And that resultant vector is now the hypotenuse of a right angled triangle. And to find the hypotenuse of a right angled triangle where we have two of the sides, we can use Pythagoras, right? So this resultant vector, right, is going to be, I'm just going to cheat here and write the formula like this. It's going to be the 17.06 squared plus the 2.22 squared. After all, this lesson isn't about Pythagoras, it's about forces. So 17.06 squared plus 2.22 squared, and then I get an answer of 17,20 newtons. And that then is the resultant force if we add those together. Now note that we're not done because we need to give a direction, right? So to get the direction, we would call this angle here alpha. Oh, that's not an alpha, that's a theta. We'd call it theta, and then we can simply use the fact that tan theta is equal to the opposite over the adjacent, so the 2.22 over the 17.06, right? And then to find the theta, we know we have to use the inverse tan function. So if we use the inverse tan function, that tan -1 thing, then we can go tan -1 of 2.22 over 17.06, put it in our calculator, and it says that theta is 7.41 degrees. Thank you, calculator. So theta is going to be 7.41 degrees, and thus we know that this 17.20 newtons is at an angle of 17.41 degrees south of east. Okay, so basically down from right. Okay, fantastic. So now it is your turn. Please pause the video and try this, find the magnitude and direction of the resultant force. Fantastic, I hope you gave that an honest try. So let's see what the result is here. Okay, so very quickly, this 40 Newton force we can break up into an X, we can break it up into a Y. Those are perpendicular to each other, so we've got Fx, Fy. And notice here that the X is next to the 30-degree angle, so we're going to use cos. So Fx is equal to cos 30 times the actual force there, the hypotenuse, which is 40, right? And then we're going to go 40 times cos 30, and we get 20 root 3, 34.64 newtons. Perfect, 34.64 newtons. And then this Fy is now opposite the 30-degree angle, so we've got to use sine. So 40 times the sine of 30, and sine 30 we know is a half, so this is 20 newtons. Okay, so now we've broken that into components. So in the x direction we've got this 44.64, and in the other x direction we've got this 10, and then in the y going down we've got this 20 now, right? And so we can add up the two vectors in the horizontal line of action. So I'm going to take rightwards as positive, which means I take the 34.64, I subtract the 10, and so I then get 24.64. That might not surprise you. So now we've again gone through the motions. We've got 24.64, and going down we've got 20. Okay, and now we've got two vectors that are at a right angle to each other, so we can easily add them together, right? So to add them together, we have to draw them tip to tail, right? So you've got the 24.64, you've got the 20. This is now the hypotenuse, and to find the hypotenuse, again, we'll use Pythag. So if we do that, we get the root of 24.64 squared plus the root, plus 20 squared under that same root sign. And if you successfully apply Pythag, you'll get here 31.74 as the magnitude of that resultant force. And we want to find the direction. So there's our theta, right? And now we know that tan of theta is equal to 20 over 24.64. That's just for opposite over the adjacent to the angle theta. And then I'm going to use this fancy inverse tan function again, 20 over 24.64. And we are going to get 39.07. So theta is equal to 39.07 degrees, right? And then we can give our final answer. I'm going to do it here. Fres, or F resultant, or Fnet, or whatever you want to call it, is going to be 31.74 newtons, right? 39.07 degrees south of east. Fantastic. Okay.